Greetings, everybody, wherever you may be, and welcome to Kourou, the home of Ariane, for tonight's live broadcast of Ariane Space Flight number 108. I'm Joshua Jampo.
And this is Philippe Kletskin reporting to you live from the Jupiter Control Center at the European Spaceport in Kourou, French Guiana.
And it'll be our pleasure to be with you for the next hour and 10 minutes at least, we hope, as we comment on the final moments of final countdown together, and you'll see the launch of the Ariane 4 in about half an hour's time. And 20 minutes after that, the big moment, the wonderful moment for our two customers tonight, the delivery of our two satellites, which are, Philippe?
Nilsat 101, our Egyptian passenger, as upper spacecraft, will be released first. And then Bsat 1B, our Japanese passenger, as inner spacecraft.
We're coming to you, as we usually do, from the Jupiter 2 building, which is the nerve center of the Guiana Space Center here. And the countdown is proceeding normally. You can see we are 32 minutes and counting down. All is on time and on target for tonight's fourth launch of the year for Ariane, the 78th Ariane 4 vehicle, and the 11th Ariane 44P configuration. We'll get back to a little description of that when we have some time. These are the operational people and the technicians inside the fishbowl, as you can see in Jupiter. Behind them, the VIPs, invited guests, for tonight's launch. The window tonight, 48 minutes, Philippe, is that a...
48 minutes, this is a nice window.
Standard...
yeah, a bit over
time.
Average, comfortable.
The broadcast going out from our site here in Kourou to many places around the globe.
It's early evening for us, and just a bit less early in other places, a little bit more early in Washington, and nighttime in Paris.
Paris, just outside Paris at Evry. Hello to all our friends at the Ariane Space headquarters. And of course, our customers taking the feed tonight in Cairo, our Egyptian friends, and the Bsat people out in Tokyo.
Good morning to Tokyo, where it's early morning.
From our launch base here on the equator, we can launch to the north and to the east. We're going east tonight, which is where we go for about 3/4 of our launches, where we put the telecom sats.
This is very handy to launch into a geostationary transfer orbit. Tonight we have a 44P Ariane, which means we have 4 solid strap-in boosters.
The P for poudre or powder in French.
This is correct.
And you can see the builders, Daimler-Benz and the others, the 8 or 9 industrial partners, contributors to the Ariane program since the beginning.
Nilsat 101 weighs in at around 1,840 kilograms launch mass for a Nilsat company of Egypt, manufactured by Marconi Space.
The upper berth meaning that they will be delivered first.
They will be delivered first. And Bsat 1B at 1,230 kilograms for the Bsat company of Japan, manufacturer Hughes Space and Communications from El Segundo, California.
The Ariane launcher mission puts the satellites into what we call a transfer orbit, and then later on the satellite on its own power will move up with apogee motors into its orbital slot.
This is right. We're now back to looking at our launch vehicle standing on the pad. The status report panels tell us that everybody's reporting a green status, meaning everything's running smoothly.
Many people working across the launch base tonight, but we have our cameras in here, but we don't want to forget all the weather people and the telemetry people and the launch base site people. And we'll be going up there and looking at some of those offices shortly. But all their information comes in here to the Jupiter building, to these two men.
The mission director and the director of operations. The director of operations oversees all the various means and players on the launch base. Not just the launch vehicle and the satellites, all the other means around.
He's called the DDO, and you'll hear his voice at certain key moments in the countdown. Pierre Ribardière, the dean of the DDOs, this is his 22nd launch tonight.
And a movie about Ariane space will be shown to you in a few seconds.
But first we wanted to show you some of the other sites. We mentioned there are a lot of other people working on the base tonight. This is the CDL, as you can see, which is the launch center. They are about 14 kilometers away from us to the northwest. And this man, Jean Rabou, what we call the COL, who's the launch operations manager, is that right?
This is the big chief. That's the person who coordinates all operations happening on the launch vehicle itself.
And they're his crew checking out the final
all aspects of the launch vehicle.
28 minutes and counting down. Ariane waiting on the pad for the launch tonight of Egypt's first satellite, actually the African continent's first satellite. A big moment for that country, of course. Ralph Yeager, Senior VP of International Affairs for Ariane Space, representing Jean-Marie Luton, the chairman, from whom we will hear after the launch. But right now, take a look at a film to tell you a little more on Ariane Space, which is the world's first transport space company.
Formed in 1980 as the first industrial and commercial space transportation company in the world, Ariane Space operates the Ariane launch system developed by the French space agency CNES on behalf of the European Space Agency ESA. Ariane Space demonstrates European scientific and technical capabilities and has the backing of the space industry and banks of 13 countries. Ariane Space operates worldwide, with its European headquarters at Évry, just outside Paris in France, a subsidiary in Washington, D.C. in the USA, a branch office in the Asia-Pacific zone located in Tokyo in Japan, and a launch complex in Kourou, French Guiana, with a unique geographical position close to the equator. Combined with the extremely accurate orbit injection of Ariane, this equatorial position extends the life of the satellites. Constantly adjusting to changes in international market demand, Ariane Space provides customers with a complete, personalized range of launch services based on extensive experience and a highly reliable vehicle which can place payloads of up to 4.8 metric tons with Ariane 4 and in the near future 7 tons with Ariane 5 directly into orbit. Ariane Space is engaged in a long-term production program with its European space industry partners. The manufacturing, which follows a tight quality policy, is permanently aimed at meeting customer requirements worldwide. "12,000 highly qualified Europeans are engaged in this manufacturing activity. The success of this venture is largely due to the power and cohesion of the industrial partners involved. The principal contractors are Aerospatiale, SEP, DASA, the Fiat Group, Matra Marconi Space, CASA, Oerlikon Contraves. The various launcher sub-assemblies are built in Europe and taken by sea, air and land to the Kourou spaceport.
And we're back on our picture of the launch vehicle. Status is green everywhere. And now we're going to see a little movie about the launch vehicle preparation campaign featuring Manuel Sanchez, who directed the building of the particular Ariane rocket that will be fired today.
In March, the V108 launcher arrived in the harbour of Kourou, Paracabo, after its trip from Europe aboard the MN Toucan. It was carried immediately to the Ariane launchpad facilities. The launch campaign started on March 24th by the erection of the first stage on the table which holds the launcher till takeoff. The day after, the second stage was mated to the first one. The solid rocket boosters will be added on the launch pad for safety reasons. Then the cryogenic first stage came on top of the whole assembly. The central core was completed by the vehicle equipment bay, which is the brain of the launcher. After a period of 12 days in the preparation area, the launcher was transferred to the launch pad on its table. The cryogenics arms, which allow to fill the third stage till the end of the chronology, were closed on the launcher. The tower which protects and gives access to the whole launcher was rolled back to the umbilical mast. The two satellites were filled and put into the fairing and the spelda in a dedicated area. At J-5, the upper part was hosted into the tower and made it to the launcher the day after. After final checks, we are ready for the launch.
23 minutes to launch. We are green and go. Those green status panels up there, we want to get a good explanation of them. We mentioned before that all the other range operations from weather to telemetry...
I should tell you first, Josh, let me interrupt you. The weather report at minus 25 minutes just came in and it's very good.
So we're okay.
There's no thunderstorm around. The cloud cover is quite acceptable. The wind speeds are fine. No problem.
Good. It's been raining all week. Today it's cleared up a bit, so we should have a fine.
No problem with the wind.
About the green status panels, all the different range operations, as we started to mention, that come in here, they come in here to the DDO we mentioned, and they're summarized in a go, no-go fashion on the board there, which everybody's looking at. Can you take us through those maybe and give us a rundown?
Essentially, there are some status reports telling us what the launch vehicle is like, some status reports telling us what the payloads are like, each separately, and some others concerning the launch base means themselves. That means the radars, the telemetry systems, the logistics, what's called logistics systems, which mean power and air conditioning and everything else in transportations. The downrange stations as well, and the various means. I hope I did not forget too many. As a result of everybody being ready and sending a green report, the autorisation de lancement, which means launch authorization, remains green as long as nobody has a problem that cannot be solved in time for the launch, which is the case now. Everything is running smoothly.
Okay, 21 minutes now, and counting down. Armand Carlier, Matra Marconi's chairman, one of the VIPs, invited guests now. This is the third launch of the year for Matra with Ariane. They had Hotbird in February, the Eutelsat, and they launched Flight 107, which was last month, the Spot 4.
Here's the program manager for Nilsat, Philippe Roussel from Matra Marconi Space.
And we'll be hearing from him shortly. He narrated a film about the satellite. And with him, his deputy. When you see them on the phone, these men will be with Toulouse, I imagine, where Matra's home, or talking to the people in the S1 building, checking out their satellite.
And here's the Nilsat movie coming up.
The Egyptian satellite company is launching Nilsat 101, the first DTH, or direct-to-home, digital transmission in the Middle East and the Arab world. Nilsat is constantly being updated to match the latest technological advances in the satellite industry. It has been launched by Egypt, the land of the first civilization in the history of mankind to settle and prosper on the banks of the River Nile. Land of the pharaohs, of the pyramids, the Sphinx, and the great temples at Luxor. Today, Egypt is preparing for the 21st century revolution in information and communications by launching Nilsat at 7 degrees west. Nilsat has the strongest radiation power in the area with 50 decibel watts and to be received by 50 to 70 centimeter dishes within its coverage area using a digital receiver. Nilsat 101 offers 12 high-powered Ku band transponders, which will be bearing 84 digital television and 400 radio channels, as well as multimedia services throughout the Arab world. 75% of the channels have been booked before the launch. The satellite is to have 20 open channels and 23 encrypted. The first generation of Nilsat will be operating between 12 and 15 years, and Nilsat will have 2 ground control stations in Cairo and Alexandria. The Egyptian satellite company's Nilsat has been created in 1996. It has been supervised and closely monitored through the making of the satellite and the 2 Earth stations, and through the training of the first generation of Egyptian technicians to operate the satellite. Built by Matra Marconi Space, located in Toulouse, France, and launched by Ariane Space, Nilsat 101 is due to broadcast and serve 60 million homes in the Arab world and the Middle East, either direct to home or through cable and community networks. Nilsat 101 is about news, culture, education, economy, sports, movies, theater, family, children, and entertainment.
We're now past minus 18.5 minutes and counting down. Status reports, you see them, they're all of a nice green color, everything running down smoothly.
Patrick Loire, Ariane payload manager. You'll see his customers on either side of him. He is the what Ariane Space calls the mission manager. He's the customer interface. And Ariane Space put in place, there's Salah Hamza, who's the technical director with Nilsat. Ariane Space has put in place a rather unique customer service with these mission managers. There's a whole team of mission managers. Maitre Marconi's Andre Hardy there, with Patrick Loire. It is a single link. If you're the customer, you have a single link which gets you in at 24 hours a day to the entire Ariane Space infrastructure and, of course, the Kourou infrastructure there, trying to...
Here's Amin Bassiouni, the chairman and CEO of Nilsat Corporation.
One of the invited guests. You have this one single link, one-stop shop, if you will, making it easy for the customers with Ariane Space.
And let's look now at a movie concerning the launch campaign preparation of the Nilsat satellite.
The Nilsat 101 satellite has been transported to French Guiana on the 24th of March 1998 by an Antonov special flight. Actually, the satellite integration by Maitre Marconi Space has started in Toulouse in June 1997. During this satellite integration, the satellite was subjected to an extensive test program, demonstrating its ability to withstand launch environment constraints, as well as operation in vacuum when in orbit. After arrival in Kourou, Nilsat 101 satellite has been successfully subjected to the last checks and tests before entering into the process of propellant fueling. In fact, the biliquid propulsion system provides the necessary capability to reach the geostationary orbit from the transfer orbit provided by Ariane launcher. The satellite will be located at a fixed point in the sky at 36,000 km altitude and at a longitude of 7 degrees west. The propulsion system provides also the capability to maintain the satellite in the required orbit and attitude during at least 15 years. The satellite, after this operation of propellant fueling, has been installed on the Ariane dual launch system in upper position on top of the Bsat 1B satellite, and the launcher fairing has been installed on the 20th of April.
We are moving apace at 15 minutes and counting down. If you just joined us, this is Ariane Space Flight 108, Nilsat 101 and Bsat 1B going up. We're going to take a look at the COEL, the launch directorate again. Now, what actually is going on with the launch vehicle? I mean, they're checking out things, but the launcher is just sitting on the pad.
Actually, I hate to disappoint you, but not that much is happening with the launch vehicle itself in the last few minutes, because it is in a what's called a scheduled hold, which means for 24 minutes we got a time buffer with no activities built into the schedule, and that could be used to fix any problems that could have arisen before.
We saw Mr. Oba from NHK and Bill Pomerantz, Executive VP at HSC. Both the contracts tonight, Art Rosales of part of the Bsat team, both the contracts tonight are turnkey operations, which I think is a rarity for Ariane Space to launch two at once.
It happens. It's not that rare. It's a one way of doing it, and there are other good ways of doing it. This is a good way too. Here's Steve Klausner, the project manager from Hughes in Space and Communications for Bsat 1B.
Bsat 1B, the second of the new generation, which will bring TV service to about 10 million people, I believe.
And we're going to see shortly a movie about Bsat 1B.
Hughes Space and Communications Company will launch its 50th HS-376 satellite when it launches Bsat 1B, the second of two satellites built by Hughes for Broadcasting Satellite System Corporation of Tokyo, Bsat. It is the third launch of the year for Hughes Space and Communications Company, which has a record 16 launches scheduled for 1998, and ended its first quarter with awards for 8 new satellites. It is also the 42nd satellite to be delivered in orbit, with Hughes procuring launch on board an Arianespace Ariane 44P rocket on behalf of Bsat. The satellite, Bsat 1B, is an in-orbit backup to Bsat 1A, which was launched from Kourou on April 16, 1997. Both Bsat 1A and 1B will be co-located at 110 degrees east longitude. The two satellites will provide 4-channel viewing capabilities to homes with small, low-cost receiver dishes, serving 10 million customers. Services available include NHK, Japan Broadcasting Corporation, WOWOW, WOWO, Japan Satellite Broadcasting Incorporated, and others. Like Bsat 1A, Bsat 1B carries 4 active and 4 spare high-power transponders in Ku band, using 106-watt traveling wave tube amplifiers. Hughes Space and Communications Company, a unit of Hughes Electronics Corporation, is the world's leading manufacturer of geostationary commercial communication satellites.
And it's been uneventful. In the meantime, green status reports. The launch vehicle is standing nicely in the night.
Doing fine. Hughes has launched twice with Ariane this year.
Here's Mr. Izumi, the president of the Bsat company.
Tonight's and Nilsat, which was the first launch of 1998, Flight 105 in February. Talking about satellite campaigns now, we talked about the launcher campaign, and the satellites have their own campaign. What exactly is the structure of a launch?
Here's Mr. Yokoyama from Bsat. The launch preparations for a satellite are something very important, of course, in the life of a satellite. It's just been transported to a launch site, and you have several things to do. You have to check that the transportation was not detrimental to the satellite. You have to add and mount any parts that have not been mounted before that you have to mount last minute. You have to check it that mechanically it's functionally okay and electrically as well.
Okay, we're going to get some details on the Bsat campaign from Ron Peterson, Launch Campaign Manager, coming up.
Bsat 1B is one of the Hughes HS-376 family of spacecraft. The popular and versatile HS-376 spin-stabilized spacecraft is one of the world's most purchased commercial communications satellite models. The first satellite to be launched by the Space Shuttle, the HS-376 is built by Hughes Space and Communications Company of El Segundo, California. All HS-376 models have 2 telescoping cylindrical solar panels and antennas that fold for compactness during launch. The basic bus accommodates a wide range of customized payloads, and the satellite can be boosted by any of the world's major launch vehicles. 53 HS-376 spacecraft have been built or ordered for more than a dozen customers on 5 continents as of the end of 1997. Without compromising its proven design, the HS-376 continues to evolve to incorporate new technologies, such as more efficient solar cells as they emerge.
All right, we talked about the launcher campaign, the satellite campaign. Let's talk about the weather now, because while you were watching that short film, we had our very last weather report before launch at 10 minutes. Philippe, what have they told you up there?
Joshua, I have to tell you, I'm still listening to it, but essentially there's no big change to what I said a quarter of an hour ago, which is that the weather looks good as far as the launch of tonight is concerned.
Okay, we have certain weather constraints. There's a wind factor and there's a low ceiling factor, but we can launch in the rain. That's no problem. We have a little problem with lightning, but otherwise we're good for tonight. Michel Mignot, head of the CSG, directing this vast operation here, which has been working for 30 years now. CSG was built in the 60s. roughly 14 sites were in competition for the new European launch base, from Australia up to Finland. And Kourou got the nod mainly because of three reasons: the equatorial site, which we mentioned, and the ocean access, which we'll get back to and talk about.
Scheduled heavy maintenance of the facilities have to be intertwined with the ongoing launch preparations on the LA-2 and also on the LA-3. Maintenance is an important task. It is crucial to guarantee availability of the launch area throughout launch campaigns coming in quick succession. Making the schedules all fit together is a challenge. After Launch 107, maintenance crews seized a 2-week opportunity to perform an extensive operation on the gantry rail track. This was a two-pronged operation. On the one hand, cracks had to be fixed. On the other hand, repairs made earlier had to be inspected. In addition, we saw that we needed to try a new type of maintenance on the sections of rails to which the gantries rolled. So we installed new rail supports. All our rails are equipped with neoprene supports, which is a rubber-type material that does degrade over time, albeit slowly. We're always trying to find better methods to slow this erosion. Our goal is even to do this well enough that this would be the last time this is carried out on the LA-2. We're going to monitor the status of these supports over the next few months, during which they will have gone through several gantry withdrawals. Then we can decide whether a new method is suitable in order to reach this ambitious goal, and if it is, we will implement it on the rest of the tracks in late 1998.
Coming up on the 6-minute mark now, you'll hear the DDO call out 6 minutes, which is a major milestone in the final countdown here, where we move into something called automatic sequence.
It's actually called the synchronized sequence. It has something automatic to it, but the classical word is synchronized sequence because all the various means have to be synchronized by the calculators, by the computers to start this.
À tous de l'EDO, attention pour le début de la séquence synchronisée de lancement. Top, moins 6 minutes, début de la séquence synchronisée de lancement.
Okay, Pierre Bardier, DDO, has just called out the 6-minute mark. This is his call. This is the DDO's call, right? He decides if we're moving into this final phase, yeah?
He decides whether we're moving in this within the range of the possible, which means that everything has to be ready to move into that synchronized sequence. He gets this information from his various staff sitting around him, who in turn collect their information from the various subsystems they're responsible for.
Okay, so what exactly is synchronized sequence? I think it's, we can describe it as the computers taking over, as moving the ground. We're going back up to the CDL now.
To the CDL, yeah, where they're very busy with the launch vehicle, because I told you earlier that the launch vehicle was in a scheduled hold, nothing was happening, but that's no longer the case now, because in the synchronized sequence, lots of things have to happen. And as a matter of fact, that's the reason that the calculators, the computers, are taking over at the last minutes, because for human interventions that would be too intricate or too, let's say, coming in too rapid a succession.
What are the computers doing now?
There are two computers. One computer is taking care of all the fluid systems, and the other one is taking care of all the electrical checks.
Fluids meaning what, propellant?
Propellants, essentially, and also pressurization gases. We're now at minus 4.5 minutes, and we have events like the pressurization of the cryogenic tanks.
There's the Egyptian Minister of Information, Mr. El Sharif, leading the Egyptian delegation down here tonight for the launch. Ariane Space very proud to be part of the occasion, the launch of Egypt's first satellite. The shots you're looking at now were taken about 5 hours ago. This is the gantry withdrawal from the launcher, one of the last major events before liftoff took place this afternoon. You can see what the weather is like. Why do we wait till the middle of the afternoon to do
We
this?
simply want to protect the launch vehicle as long as possible from anything that could happen. Also, we want to have easiest possible access to anything on the launch vehicle until the last moment. In this particular case, in the afternoon of the launch, we're back now in real time, let's say.
Now, we're coming down on 3 minutes now. It's up at the launch base again. If there's any red, if there's any anomaly found, we stop the synchronized sequence, right? And then we have to move back to the 6 minutes.
This is right. Yeah, this is correct.
Now, why can't we go down to launch time manually?
Everything is synchronized as the name implies, which means that we do have to go back to a particular, very well-defined configuration, which is the one that's defined for -6 minutes. After that, if something goes red, it means something went wrong, and this first has to be fixed, and the configuration has to be put back into exactly the one which is exactly well-defined for the beginning of the synchronization of all those various events. This is why it goes back to -6 minutes and starts again when that happens, but fortunately, until now it has not occurred.
Now the seconds are ticking away perfectly. So far, the countdown perfect at 2 minutes and 44 seconds.
As we were talking, as a matter of fact, the liquid hydrogen tank of the third stage has been pressurized to flight pressure, and this is being the case right now, or just about, for the liquid oxygen tank.
A little earlier, at -3 minutes and 30 seconds, the satellite goes on launch configuration, which means what exactly?
All right, that's different.
Power?
That's not a launch vehicle. That's on the payload and the satellites. It means, yes, they do switch from using ground power to using their onboard power. Of course, they don't want to do that too early, because there's no sense in using your onboard power when you can still rely on ground, but you do have to switch to onboard power at some point.
So in other words, during this synchronized sequence, everything is passing, power is passing from the ground to the launch vehicle, more or less.
I would not call it power passing to the onboard. I would call it switching from a particular source on the ground to an onboard source. This happens to the launch vehicle at -1 minute, by the way.
Okay. Coming down to the last minute now before launch. All eyes are forward on the green status panels, which continue to tell the story. We're green and go. This is a very interesting shot we want to take you through a little bit, because it's the last image that you're going to see before we have liftoff. These cryotechnic arms, these are the feeder arms into the third stage, feeding the propellant, the oxygen and liquid hydrogen.
Yeah, we want to have them until the last minute, because we're topping up the tanks as long as possible so that the stage takes off with the optimum amount of propellants for both of them.
And you'll see these arms swing open just before Ariane will lift off. For Ariane to leave the pad, the arms have to...
Attention pour H-1 minute.
He's going to call out the 1 minute mark.
Top, -1 minute.
All right, the final 60 seconds now. So in order for Ariane to lift off, these arms have to swing open. If we
They
don't
have to swing open,
arms, we don't have
otherwise, of
liftoff.
course, it prevents the launch vehicle from taking off. And we do it as late as possible so that we can top up the tanks, as I explained before, until the very last minute.
Okay, and briefly, just before we cut away and let people watch the last seconds of liftoff alone, what's the ignition sequence now? We have the arms swing open?
The arms will be commanded open at -5 seconds, and then H0. The computers will check, of course, that it has been retracted.
The same computers we were talking about in synchronous
Yes.
sequence, yeah?
Yeah, and if they sense that the retraction is not complete, of course, they would not authorize ignition. H0 is
Tous
ignition.
LDO,
Let's listen to
attention
it.
pour décompte final.
Final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage. Tous les paramètres au bord sont à go. Les paramètres sont normaux et la trajectoire est normale.
Normal trajectory, normal power, says the DDO.
Extinction des propulseurs d'appoint.
The solid boosters have already done their job.
Burned out, and they will shortly be jettisoned. Ariane rising into the night sky now. You see her rise over, then she tilted into a plane, which is in the onboard computer. Now she tilts over because it's a very simple matter of better
Les
radar.
paramètres sont normaux
Well,
et
there
la
are actually
trajectoire est
two
normale.
separate maneuvers being carried out. One maneuver is to pitch in the plane of the trajectory, because simply it's not supposed to go straight vertically to optimize the trajectory. The second maneuver is a roll maneuver around its axis, around its
Largage des
velocity axis.
propulseurs d'appoint à poudre.
Yeah, the solid boosters have been
Tous les paramètres sont
jettisoned.
normaux et la
Everything
trajectoire est normale.
Yeah. We can hear the rumble of the launch vehicle as it passes overhead. This is very impressive, as every time.
Takes about a minute and a half for it to get here from the launch.
Yes.
All right, give us a quick rundown on the blue.
What you see on the screen on the right-hand side tells you a lot of interesting information. The time that has elapsed, of course. Moyen, that's a French reference to which means of
Les paramètres
tracking
à
is being
bord
used.
sont normaux
In this case,
et la
it's
trajectoire est normale.
in this case, it's in a dual radar based here in Kourou. S means site, and that's the angle under which the receiving antenna gets the signal from the launch vehicle. A is the altitude, and V the
Les
velocity.
paramètres
Kilometers per
propulsifs
second.
sont normaux et la trajectoire est normale.
Everything's normal, says the DDO. First stage burning roughly 2 tons of fuel per second. I think that's.
And now we switched from the dual radar to the Bretagne radar. The site is still increasing, which means
trajectoire normale.
as the launch vehicle altitude increases, and it's still not that far away, the ground station sees it under an increasing angle, which is in general favorable. Later on, you'll see that that angle decreases again, and then the ground station will hand over to the next station. But for now, it's still followed by the Bretagne radar in French Guiana.
La trajectoire est normale.
Everything normal, says the DDO. First stage is still burning. It'll burn for another 30 seconds or so.
La propulsion est normale et la trajectoire est normale.
And it's dropped out over the Atlantic, just like the boosters. One advantage of this site is you can shoot out over the Atlantic and drop things where there's no population.
Actually, the boosters often land on land, which is very handy because occasionally...
Extinction du premier étage.
There's the first stage
Very good.
burnout.
Séparation du premier étage.
Separation of the first stage.
Allumage du deuxième étage.
And the second stage has begun. It's
been
burned.
ignited. The first stage is going to fall back into the ocean. It uses some, there's a pyro core, the
Les
pyrotechnic system.
paramètres propulsifs sont normaux et la trajectoire est normale.
How does the onboard computer know when to separate the stages? I assume that's built into the onboard computer.
It's built into the onboard computer, but the criteria for separation commanding are different for each of the 3 stages. For the first stage, it's a matter of using all the propellant on board, and when the computer senses that the acceleration imparted by the first stage is below a certain percentage of its nominal thrust, it decides, well, the thrust is building down because the propellant
Les
has been
paramètres
exhausted.
bord sont normaux et la trajectoire est normale.
And then it commands the shutdown of the first stage and separation with the pyrotechnic cord, and the ignition of the little retro rockets that will ever so slightly break the first stage to make sure it neatly
Largage de la
separates.
coiffe.
The fairing has been jettisoned now.
Fairing has been jettisoned
Very
now. This happens at about 110, let's see, 119 kilometers up.
Yeah, that's because at that altitude the atmosphere is thin enough that there's essentially little effect from friction on the atmosphere. It happens at a predetermined thermal flux on the payload.
It's more or less the same separation system as the stages.
Yeah, there are some differences, but essentially it's a pyrotechnic system, just the same.
Take a look at our mass profile of the launcher
Les
now.
paramètres bord sont normaux et la trajectoire est normale.
Normal, says the DDR. Total mass at liftoff about 354 kilos. And when we dropped the first stage, we were down to 56.
Joshua, fortunately, it were tons.
Tons.
The lift off.
What did I say?
is handier.
354,000 kilos. Yeah,
Yes.
right. And we're down to 56 tons.
Yeah.
Now after dropping the third stage. So we lose a lot of mass and a lot of
Yeah, this is the way it should be.
Mainly propellant filled, I guess.
It should the way it should be. The stages should be mostly propellant and very little anything else, because the ideal launcher would have only propellants on board,
Extinction du deuxième étage.
except for the payloads. The second stage has been shut down
Séparation du deuxième étage.
and jettisoned.
There's the separation.
Allumage du troisième étage.
Ignition
And
of the
the third stage has begun to burn now. This is, we're into the long third stage burn, which will be going for about 12 minutes. A little different third stage than the other two, huh?
Yeah, just take a look at the S parameter here at the site. So yeah, I had been telling you that the site would be
Les
decreasing,
paramètres propulsifs
It's
sont
gone down.
normaux et la trajectoire est
and
normale.
it keeps going down, which is normal. And at some point it will be so low that the Bretagne radar, which is now tracking the vehicle, will not get a very good view of it any longer, and then there will be a handover to the next station.
You see on the bottom the V, the velocity, about 5 kilometers per second. This is roughly half the speed we need for
Somewhere
satellite.
there. Yeah, somewhere there.
So the third stage will get us to 10 meters,
Yeah.
kilometers per second.
Acquisition par la station télémesure de Natal au Brésil.
The downrange station in Natal, that's our second downrange station after French Guiana, has now gotten sight of the launch vehicle and receives the signals.
We have an agreement with the Brazilian government there that let us use these facilities. I think some additional ESA equipment, European Space Agency equipment.
Exactly. It's a Brazilian station with ESA equipment.
Third stage has
Les
10
paramètres
tons.
propulsifs sont normaux et la trajectoire est normale.
10 tons of cryogenic fuel, the liquid hydrogen and oxygen, which were used, by the way, for the very first time outside of the U.S. on Ariane Space Flight LO1 on Christmas Eve of 1979.
79, and that was a big success.
Now, the third stage will push Ariane across the Atlantic roughly in a southerly direction. She'll cross the equator, and the two satellites will be released, one on the west coast, one on the east coast of Africa. We're now flying at about 226 kilometers up, a little over 5 kilometers per second.
You asked a question earlier about the separation criteria. I cut you off at the time, but I can tell you now that on the second stage, the onboard computer decides to shut it down when the second stage has done a certain fixed amount of work. It's not the same as the first stage. You remember that one was
Les
a
paramètres
detection
propulsifs sont normaux et la trajectoire est normale.
of propellant being exhausted. In the second stage, we don't want to exhaust the propellant fully. We want a very neat burnout of the stage, and therefore the onboard computer measures the delta velocity imparted by the second stage, and when it has worked sufficiently, shuts it down, separates it with a power cord. And the third stage is then ignited. It's a bit different from the first and second stages because the propellants which are used are different. In the first and second stages, the Ariane vehicle uses what's called storable propellants, and they're hypergolic. Now that sounds like a bit of a barbaric term, but it's actually very simple. It means those propellant are energetic enough that when they feel each other, they ignite
Les
spontaneously.
paramètres bord sont
So you don't need
normaux et la
to
trajectoire est normale.
put any match to it or anything. It just ignites. Now, on the third stage with the cryogenic propellants, it's a little bit different because chemically they're less reactive to each other, and you do need to ignite them. So there is on the third stage a whole ignition system. And that doesn't mean that they're less energetic, by the way, because cryogenic propellants are the highest possible propellants as far as specific impulse is concerned, which is the measure of energy content for rockets.
But a little more delicate to maneuver than solid.
I wouldn't call it more delicate to maneuver. I would simply call it a more advanced technology that has been used by Ariane since the very inception of it.
All right, take a look at the cursor on the left. You see the curve that goes up and then down. On the right of your screen, X to H10. That's extinction of the third stage, which is also called the H10. That's how long we have to go.
Yeah, you see that actually you would perhaps expect the trajectory to be monotonous, meaning
Or
increasing all the time.
constantly, yeah.
But that's not the case because very simply it is advantageous to go as fast as possible through the atmosphere and then let the altitude decrease a little bit while gaining velocity. So the actual optimum trajectory has this sort of hump in it that looks a bit funny but is very efficient energy-wise.
Is that what the French call reculer pour mieux sauter?
You can call it that way. I'll leave the responsibility to you.
All right, we're 250 kilometers up, and we're approaching
Tous les
6 kilometers
paramètres bord sont normaux et la trajectoire est normale.
per second, and everything is normal, says the DDO.
And you can tell from the moyen thing here that we are
Perte
getting
normale par les moyens
telemetry
de Kourou.
CIS?
and perte from Kourou. That's what the DDO just said. This means that the Kourou stations have lost sight of the launch vehicle.
Which is normal.
Which is
Picked up
normal.
by the-
It's just beyond the Kourou horizon, let's say.
Coming up on 11 minutes into the launch now. Third stage in the middle of its burn. All is going very well and all is going normally. We got time for the quiz, you think?
Go ahead.
Tous les paramètres bord sont normaux et la trajectoire est normale.
All right, we always like the third stage burn because it gives us a little chance to spread out because we have some time. And we like to take advantage of it and give you the Ariane Space quiz. Tonight's question, quiz number 108, everybody, if you're ready. You know that we mentioned tonight's is the 11th satellite we're putting up for Japan. Our question is, what is the total tonnage for Japan that Ariane
Tous les paramètres bord sont normaux et la trajectoire est normale.
has put up since Ariane, the Ariane family began service? Again, question number 108 tonight. The total tonnage for satellites that Ariane has put up for the nation of Japan. You get to work on that, and we'll give you the answer in a minute. But before we do, take a look at our mass profile again. You remember we started at 354 tons. After the first stage separation, we were down to 56 tons, almost 57 tons. We dropped the second stage, we were down to 17 tons, and we're now flying with that. Once the third stage will be dropped, we'll be down to 5 tons. That's just the 2 satellites and the adapters and the Spelda.
Actually, this is very good, you know. As I mentioned earlier,
La trajectoire est normale.
For an
Et les paramètres bord sont normaux.
everything is running smoothly. For an ideal launch vehicle, you would like it to be made almost entirely of propellants. Actually, for an ideal one, it will be really only propellants and the payload. Now, that's not physically possible, of course. We do need structures and tanks and motors and engines and everything. But the more propellants
Acquisition du lanceur par la station télémesure de l'île d'Ascension.
The DDO was just called out. We've been acquired by our second downrange station out in the Atlantic, Ascension Island, which is an ESA station built there in 1991 when NASA was going to close its support station there. And we're still being followed by Natal in Brazil, right?
Yeah, Natal has not lost sight yet. There is overlap, and this overlap provides, of course, it gives a choice for a few seconds of which mean to use, and also it makes sure that we never lose sight of the launch vehicle during its boosted trajectory, during its boosted phase.
As you mentioned, it's this, I guess the best system we have, but we have 354 tons, putting up a total of what is 1% of for payload.
It's 1% when you go to GTO, yeah, which is you should be careful which orbit you're talking about, but because if you're talking about low Earth orbit or GTO or GEO, of course those ratios change every time. But for GTO, 1% is a reasonable rule of thumb.
Les paramètres propulsifs sont normaux et la trajectoire est normale.
Talking about acquisition of these satellite stations, what exactly do you mean by acquisition? Yeah, it's a bit of a jargon word, but essentially it means, as I explained before, that the satellite comes like a star. You know, it's like a rising star. The satellite will appear above the horizon, and the antenna of the ground station will suddenly sort of see. I say see, but it means, of course, radioelectrically, pick up the signal. The spacecraft rises above the horizon, and as soon as it's clear, it's far enough from the horizon that the signal...
du lanceur par la station de Natal au Brésil.
All right, DDO has just said we've just lost, the Natal has just lost the signal, which is normal. So we're being followed only by Ascension Island now.
No, it's only by Ascension. And when the spacecraft is high enough above the horizon, the signal can get neatly into the antenna that's looking at it. So it's really like a star rising and then setting. And in this particular case, the launch vehicle has set as far as Natal is concerned. It has disappeared below the horizon. Now, of course, the geographical horizon and the radioelectrical horizon are not exactly the same, because sometimes you can follow a source broadcasting from slightly under the horizon, or sometime you lose it just before the geographical horizon because of the particular electrical configuration of the geography out there at the time.
Now, these downrange stations, which give support to our own stations here, once they receive the signals, they send everything back immediately to us in Kourou.
They don't send everything back in real time. They send part of what they receive back. It would be actually too much to send everything back in real time. But they send the most critical parameters, and they, of course, tape everything. And some of the parameters are useful not right on the spot, but they're useful later on to be able to diagnose what happened in the launch vehicle.
Analysis and flight,
Or post-flight analysis.
But it's very important, obviously, to have immediate visual data on what the launcher's behavior is and the pressures and the engines and things.
Of course, the main propulsion parameters and trajectory parameters, these are relayed in real time up to Kourou, to our people manning what's called the CV,
La
or
trajectoire est
CVI,
normale et les paramètres bord sont normaux.
which means sort of immediate
Visual
control,
room, I think,
compte rendu.
Yeah.
And they look in real time at all those crucial and critical parameters to know immediately what's going on the launch vehicle.
All right. You see our speed is 8.4 kilometers per second. We have to go to 10 kilometers per second roughly.
Just short of that, yeah.
Yeah, so we're still picking up speed now.
Yeah, less than 2 minutes of boost phase left on the
third
stage now. Yeah.
Well,
It's the
then
smallest of the three, but it's the one that is actually boosting the
Tous
longest
les
time.
paramètres propulsifs sont normaux et la trajectoire est normale.
Everything's normal. Well, if we've got 2 minutes left, we better give you the answer to the quiz. The question was, what's the total tonnage of all the cumulative Japanese satellites that Ariane has launched?
Let me give a guesstimate.
Go ahead.
19.5 tons.
19.5 tons. Well, tons. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 satellites. I get 22 tons for 9 satellites.
Even better than what I thought.
You weren't far off. A third of them, by the way, 3 of the 9 built by Hughes. Some JC Sats and Bsat 1A, of course. So for all those who got the right answer, 22.1 tons, roughly 22 tons. Give yourself a round of applause.
You know, we have a downrange station in Libreville in Gabon, in
Which should be
Africa.
picking us up.
And it will see, again, to use the same example, it will see the launch vehicle rise above the horizon in another few seconds.
And I think the Libreville station is the
Il
one that
reste
follows.
moins d'une minute de propulsion.
Less than 1 minute, says the DDO in the third stage burn. Libreville is the final station that tracks the end of the Ariane mission, correct?
That's correct. Yeah, it tracks it until the end. Let me say, it does not mean 1 minute to the end of the mission. It means 1 minute to the end of the third stage propulsion. That's different. The launch vehicle still has work to do after the shutdown of the third stage.
Which we'll get to once we
Yes.
once we get to that point, sure.
Acquisition par la station de Libreville au Gabon.
All right, there
Here
is,
it is.
there's Libreville. That was an ESA station also built in 1987. There's some shots of it there you can see in the upper left.
So you see our Ariane vehicle has managed to cross the Atlantic and be up there at 225 kilometer up at nearly 10 kilometers per second.
Crossing Atlantic in about 20 minutes.
Not bad.
Extinction du troisième étage.
There's the end of the third stage burn, which has pushed Ariane all across the Atlantic Ocean.
And to continue on how does the computer know when to
Début
shut
de la
down?
première orientation du composite.
Okay, now
Right now
first,
what's happening?
Nilsat.
There's some special maneuvers that have to happen before we can't separate the satellites now.
the third stage first has to get into the right orientation to perform the separation, and that's what it's doing right now. There's a system on the upper stage that does just that. Orientation, and that will be followed by separation of the Nilsat 101.
Just to finish off with our mass profile, remember 354 tons at the beginning. We're down now to 5 tons after we've dropped all the stages.
Perte du lanceur par la station d'ascension.
And Ascension Island has lost the signal now, which is also normal,
Yep.
so we're followed only by
L'orientation du composite
By
se
Libreville.
poursuit.
our final
Normalement.
tracking station.
The upper stage system is doing its job of getting to the orientation that's required for the separation of Nilsat 101. This does not mean that Bsat 1B is being forgotten in the meantime. Its turn will come, and the orientation will change between the first and second separations. Now the altitude is increasing rapidly, which is in accordance with the laws of celestial mechanics.
The excuse me, the Nilsat contract was, I think, signed in '95, originally with Egypt State TV and ERTU, and then the Nilsat.
Fin de la manœuvre d'orientation au bénéfice de Nilsat.
Yeah, the orientation is now okay for separation of Nilsat.
Nilsat company was created shortly afterward. The contract calls for one orbiting satellite and one ground spare. And people from Matra told us that they are preparing the backup to be launched, if necessary, in a year. Talking about some possible modifications to it as well. But
Mise en rotation du composite.
okay, now the orientation, that was one thing, and the next thing is the vehicle has been spun up around its axis, its longitudinal axis.
spun up.
It will rotate around itself. That's to achieve better stability. It's not a quick rotation. It's a few rotations per minute, a few RPMs.
Séparation Nilsat 101.
Nilsat 101 separated.
Good news for Nilsat.
Very
Arrêt
good.
de la rotation.
All right, and now
And you can hear the applause.
the vehicle has been spun down, which means the rotation is cancelled.
But the mission is not over. We still have one to go.
Yes. We still have a couple of things to do because, as I mentioned before, Bsat 1B also has to be oriented and separated properly. And that's why first the rotation of the vehicle was slowed down to nil, so that it
Début
could
de
be...
la manœuvre d'orientation.
Exactly, so that it could be reoriented in another direction according to other criteria,
This
according to
happens-
the second customer
It
criteria.
happens on every double launch.
It happens on every double launch. Ariane has this great capability of providing each customer with the separation criteria that are part of that customer's requirements separately.
All right, now that Nilsat is up, tell you a little bit of what's going to happen to it up there. It'll be
La
first,
manœuvre d'orientation se poursuit normalement.
all right,
Okay.
first picked up by Perth in about 20 minutes, they tell us. And the first apogee motor ignition will be on April 30th, they say. There'll be another one on the 1st of May and a third on the 3rd of May. Solar panel deployment May 5th. Antenna deployment the next day. And then after about 3 weeks of testing, should enter service at the end of May for the Gulf nations and North Africa.
You see that the velocity is decreasing very slightly, which is of course normal since the altitude is increasing.
Started to mention that there are two ground stations. There's one big one in Cairo called 6th October City. That's the main one with two antennas. And there's a backup station in Alexandria with one antenna. That was whole part of the contract. There's also a TV production site, which was part of the picture, called Media City, which is nearby 6th October City. And that'll open many new TV channels for the satellite. It's the roughly the same investment as the satellite, about £1 billion.
We're now waiting during the orientation phase for Bsat 1B. And first, the Spelda has
Acquisition
to...
par la station de Malindi au Kenya.
All right, and now actually there's another station, but that one is not fully indispensable for tonight's mission.
Séparation du capot de la mini Spelda.
Okay, so there was an orientation phase, and the separation of the upper part of the
He
Spelda
talked
occurred.
about what's Spelda.
This is a structure, it's a
Début
piece
de
of
la phase
structure
d'orientation du composite au bénéfice de Bsat 1B.
that houses the inner satellite, if you like, and supports the upper spacecraft.
So it's not enough to be inside the fairing. You have to have some sort of
It's different.
Inner.
It's different. The outer skin of the Spelda is also the outer skin of the launch vehicle at that level. The fairing is on top of that. The Spelda is not inside the fairing.
So we're being spun up or spun down now for
No, it was a reorientation. There was no
L'orientation
spin.
se poursuit normalement.
It's a matter of now getting into the right orientation.
And you can see as the cursor climbs up the curve, that'll be separation of Bsat 1B.
Yeah. Essentially, what you want to do is separate all three objects: the first spacecraft, the top of the Spelda, and the inner spacecraft, in three different directions, so that that excludes any risk of later collision. Also, the spent upper stage itself, after it has separated the second spacecraft, performs a maneuver to exclude any risk of later collision during the orbit. That's why you'll see that the end of mission of the Ariane vehicle is actually somewhat later than even the second spacecraft separation.
Mise en rotation.
Now it's a spin up.
It's a complicated set of maneuvers.
It's okay. The onboard computer can take it. It's even pretty standard for the Ariane onboard computer, and actuation systems that go with it.
Séparation Bsat 1B.
Well, there we have the good news. And the handshakes and the applause as Ariane has successfully fulfilled her mission. The two satellites
Arrêt de la
now
rotation.
delivered.
And spin down of the upper stage.
We can give you some of the operations for Bsat now that's up. That'll be first acquired by Castle Rock in Sydney in Australia in about 13 minutes from right now. And then at the 8th apogee motor, about 76 hours after launch, we'll have the first kick motor for Bsat 1B, joining its companion Bsat 1A up there. We will go to the traditional speeches shortly. We'll be hearing first probably from Ariane Space Chairman Jean-Marie Luton, who is in Paris at the Museum of Natural History, I believe, where there's a big gala with about 300 invited guests, and he'll be visiting us by phone link up. And then we'll be hearing from Armand Carlier-Matra, and the information minister from Egypt, Mr. El Sharif. And
we'll first take another look at the takeoff, which was so spectacular.
Launch replay coming up.
Launch replay. For any of you joining us lately now, this is a replay.
we mentioned the people in Paris taking us from the Museum of Natural History tonight in Paris. What's that all about, Philippe?
Ariane Space is contributing to an exhibition by France's National Museum of Natural History. It's called Scientists in Egypt, from March 11th to July 6th. Nilsat, which is, as you mentioned, Egypt's first satellite, will be exhibited at the museum. That's in a display which will be supported by Ariane Space as Nilsat's partner. Just as scientists contributed to better knowledge of the past Nile civilization, Ariane Space, Matra Marconi Space, and Alcatel Espace, who are partners of Nilesat satellite program, are contributing that way to better knowledge of modern Egypt.
All right, we're waiting for the phone link up, I believe, with Paris, where we'll hear from Chairman Luton, and then the other speeches. We'll also hear, I mentioned, the Information Minister, Mr. El Sharif, and Bill Pomerantz from HSC, and Takehiro Izumi, Bsat President. All those gentlemen scheduled to speak.
While we're waiting for the first speech, I would just like to say that on the replay, on the launch itself, we saw that the exhaust from Ariane looked very dark. That's because it was an infrared picture, of course. Do not think that it's bad.
Messieurs les ministres, Excellences, Ministers, Excellencies, it's with real pleasure and pride that we can declare further success for Ariane. It's the fourth Ariane launch of this year, and Ariane has succeeded its mission and placed into accurate orbit the two spacecraft entrusted to us by our customers. Nilsat and Bsat B1 for the Japanese company Bsat. This is not the 36th successive launch for Ariane, and it is due to all the technical, industrial, and operational teams. The teams from the Guyana Space Center, the European industries, and the teams at Ariane Space. They are the ones who guarantee the reliability, the availability of the launch and the quality of the launch service. Thanks to their competence, thanks to their continuous efforts, Europe confirms its leadership in the field of launch services. The market is growing. Ariane Space is taking the right decisions at the right moment with its industrial partners in order to respond to the needs of the operators worldwide under the best economic conditions. Ariane Space has a continuously high order book, 39 satellites to be launched. Bsat and Nilsat, I would like to thank you for the trust you have set in Ariane Space. For Bsat, it's the second satellite we're launching. This spacecraft is meant to broadcast analog data, and it is Nilsat that is going to transmit and broadcast television programs to the entire Arab world. These two operators have joined the family of the spacecraft entrusted to our company via Matra and Hughes. We thank them all for the trust they've set in us. We have with these two manufacturers, those who have launched most spacecraft with Ariane Space. We hope that Matra, Hughes, Nilsat, and Bsat will come back to Kourou soon. I hope that in-orbit operations have the same success as this launch, and that the exploitation of these two spacecraft have the best possible results for the benefit of their operators. Thank you, and it's all yours in Kourou.
So Jean-Marie Luton thanking customers for the trust in his organization and hoping that the satellite operations will be as successful as the launch. We'll go now to our other speeches.
My first words will be to congratulate Ariane Space for their excellent success. They deserve the most cordial congratulations for this wonderful success at the precise hour, at the precise moment that was forecast, and with accuracy. This is why we, with you Egyptians, chose the best launcher. Need we prove this? Ariane is the most reliable launch vehicle, the best launcher, and this was demonstrated once again this evening. Egypt is entering the club of space nations. Mr. Minister, it's the first spacecraft for Egypt, the first satellite for the African continent, and it's also for Egypt the coronation of a cultural achievement. I will therefore hand over to you, thanking Ariane Space, thanking all the teams of MMS, but also those who have contributed to this success. Alcatel, it's Alcatel who built the payload. Alcatel is our partner in many of our projects. Thank all of them, all of you, all the engineers who over 24 months made enormous efforts to be on time and accurately. So they're continuing their work. They're going to continue to work in the hours to come. I will continue to give you the good news from your spacecraft before I hand over to you the keys of this wonderful Egyptian spacecraft that you had the good idea to entrust to us. We are proud as Matra Makoni Space to be able to cooperate with Egypt today. It is symbolic, and we heard President Luton speak from the Grand Palais in Paris, where this beautiful exhibition is being shown 200 years after Champollion, a further expression this evening of the great friendship between France and Egypt, the sign of which is this successful launch. Mr. Minister, I hand over to you.
Thank you very much.
I think that there is a translation from Arabic to English and French. Excuse me, because I'll speak in Arabic to you and also to our people in Egypt who are listening now on air. السيدات والسادة، أتحدث إليكم في هذه اللحظة التاريخية.
Ladies and gentlemen, I am taking the floor today at a very historical moment on behalf of Egypt, which is stepping into the Space Club, and this is after launching its satellite successfully. History will record this moment. Egypt, under the guidance and presence of President Mubarak, has stepped into the 21st century at the right moment.
ومصر المنطلقة إلى المستقبل من قاعدة وعمق التاريخ. فمصر صاحبة
Egypt is the home to one of the oldest civilizations. It is also the home and was the home of the Prophet,
التي تسللت إلى قواعد وجذور
and was also a country and a civilization that was a source of inspiration for Greece and Rome.
بعلوم الرياضة والطب والفلك والفيزياء.
Today, Egypt is turning towards the future.
ينساب النيل في أحضان واديها.
Egypt, which is African, which is crossed by the Nile, is launching Nilsat today. As President Mubarak said, the Egyptian satellite represents a huge step into the next century, into the next millennium. And it will make it possible for the average man in the street in Egypt to receive new services and programs. This satellite will also be a bridge between different cultures and civilizations. Allow me to very warmly congratulate Mohammed Hosni Mubarak, President of Egypt,
صاحب القرار والحريص على تحقيق التقدم والبناء. وتحية إلى حكومة مصر رئيسها.
And also to our Prime Minister and to all the members of our government who have all supported this project.
لكل المصريين الأصحاب الحقيقيين لهذا الإنجاز.
I would also like to extend my congratulations to all the Egyptian people. I would also like to thank Ariane Space and the chairman and president of Ariane Space.
تهنئة إلى مؤسسة ماترا سبيس ماركوني وشركة الكتل.
I would also like to thank Matra Marconi Space and Alcatel, who manufactured Nilsat.
وبأعلى التقنيات. وتهنئة إلى رفاق أعزاء.
I would also like to wish
بنجاح إطلاق البيسات.
wholeheartedly and wish the best of success to our Japanese colleagues for a very successful launch and operations afterwards. I would also like to congratulate Nilsat, the company Nilsat, for the successful launch.
وتحية إلى الإعلام المصري بكل أبنائه على هذا الإنجاز، وأقول قد حملوا الرسالة وحققوا الأمانة. وتحية واجبة إلى ممثل الحكومة الفرنسية بجيانا الفرنسية على وجوده ومشاركته معنا الآن.
I would also like to thank the Guyanese people, and I would like to wish all the other people the best of luck, and I wish that the future operations for our satellites will be fully successful. This is until they are actually positioned and find their final position in space.
وشكرا لكم جميعا.
Thank you.